Welcome to this lesson, and in this lesson we are going to be studying about object-oriented programming. So there are various programming paradigms, and one of them is procedural programming, and the other one is the one that we're going to be studying, object-oriented programming. So procedural programming is about writing procedures or methods that perform operations on the data, while object-oriented programming is about creating objects that contain both data and methods. In the previous lessons, what we have been focusing on is a paradigm called procedural programming, and just as we have described it, involves writing procedures or methods that perform operations on the data. What we are going to be learning in this lesson on object-oriented programming is about creating objects, just as the word suggests, objects that are going to be containing both data and methods. What this means is that you could have various objects that contain different data, and the methods can then operate on those different data. What is an example of an object? For instance, in your programming, you may want to represent a car or a vehicle. How would you represent this information? For instance, in a car, you have the weight of the car, the engine size of the car, the color of the car, how many wheels, for instance, the car has, and let's say the capacity of the car. But remember, in your programming, you may want to represent that one type of a car. It could be a Nissan, a Toyota, an Audi, a Mercedes, and so on and so forth. And also within those classes, car classes, you might also want to represent different types of Mercedes, Audis, and so on and so forth. Would you really have to be writing code for a Mercedes E-Class, a Mercedes C-Class, or an Audi for the various versions, uh, like we would want to do with procedural programming? This is where object-oriented programming comes in, where you can write a class from where you can now define the various objects. So you write code once and you can now be able to create multiple objects. For instance, in the car scenario that we have described, I would create a class called car or vehicle, and then I would create an object of an Audi vehicle, a Mercedes vehicle, a Nissan vehicle, and define the various attributes or the various data points, for instance, the size, the engine size, the color, the capacity of the car, and so on and so forth. Apart from having attributes or data, objects also have methods, also known as behavior. Behavior to mean what can this object do. For instance, our car object can move, can drive, can brake, can carry a load, and so on and so forth. And also it can even monitor the speedometer of the car, and so on and so forth. If we have to have a person, a class person, just as another example, the object person can have attributes such as name, age, height, date of birth, and it can have methods or behavior such as eat, walk, stand, run, and so on and so forth. So this is object-oriented programming. I hope you can be able to picture it in your mind, how we can be able to map different kinds of objects using object-oriented programming. Object-oriented programming came later after procedural programming. Procedural programming came before the object-oriented programming, and object-oriented programming has several advantages over its predecessor, the procedural programming. Number one is that object-oriented programming is faster and easier to execute, and it also provides a clear structure for the programs that you write as a software engineer. And it also helps to keep the Java code don't repeat yourself. We normally abbreviate it as dry. Don't repeat yourself, and makes the code easier to maintain, to modify, and to debug. Object-oriented programming, or OOP, as we commonly call it, it makes it possible to create fully reusable applications with less code and a shorter development time. The do not repeat yourself principle is about reducing the repetition of code. Just as we have mentioned earlier before, you do not want to write code to represent a Mercedes, an Audi, a Nissan, a Toyota. It would be too hectic and it would involve too much repetition. And you can imagine whenever you would like to change a property or some data or some property, let's say the size of the car, you would have to keep changing for the Audi, for the Nissan, for the Toyota, and all the various vehicle types that you have. What if you would only need to change once, just in one place of your code, and you can keep reusing that code? This is why we have object-oriented programming. So what happens is that we extract the code that are common for the application and place them in a single place and reuse them instead of repeating them. Java has the concept of classes and objects, which is common to all object-oriented programming languages. So classes, so in the OOP concept, what you're going to be interacting with most and all of the time is the concept of classes and objects. Previously, we have worked with classes, although we may not have delved into their details as we are going to do in this tutorial or in this lesson. For instance, in the previous classes, we have been writing a class or dealing with a class called the Java tutorial. There is a time we created another class called main, and a class is defined using the class keyword. So whenever you use the class keyword, that is used to define a class for you. And whenever you have now defined a class, you can now create objects from that class. We are going to be seeing these in a short while. So classes and objects are the two main aspects of object-oriented programming. For instance, just as another example, we can have a class called fruit, and class fruit can represent the various properties or attributes that fruits contain. A fruit could have a size, a shape. Let's say we could even define something like a taste. And what are the objects that we could create from the fruit class? We can create an apple object, a banana object, a mango object, um, a strawberry object, and so on and so forth. Another example of a class would be a car, of course, as we have defined before. So we can have objects like a Volvo object, an Audi object, a Toyota object, a Mercedes object, and so on and so forth. Picture that in your mind. So a class, by the formal definition of a class, is a template or a blueprint for creating object, and an object is an instance of that class. An instance of that class to mean, for instance, you could have two Mercedes on the road or on the parking lot. So one Mercedes, we can say that that Mercedes is an instance of a car, only that it has different properties from a Toyota. So when the individual objects are created, they inherit all the variables and the methods from the class, meaning you do not have to rewrite them, hence enhancing the concept of the don't repeat yourself principle, meaning that we want to avoid repetition as much as we can. So this is the introduction to object-oriented programming, or OOP in Java. Just a brief introduction. So in the next lesson, we are going to be studying about how to create classes and objects, and also some explanations or theory behind it. Thank you very much. Keep learning. Enjoy. See you in the next lesson.